I'm very glad that our new government is focusing on STEAM rather than just STEM subjects, with Education Secretary Bridget Phillipson's detailed policy plans to radically change our UK educational system going forward. Science, technology, engineering, and mathematics, STEM for short, are of course vital for our industries and jobs of the future. But the way that the arts have been systematically undermined and underfunded for the last 14 years is shameful. Access to drama, books, music, museums, film, theatre, modern and traditional art, opera, classical and popular music, history, archaeology, anthropology, linguistics, and all kinds of international culture, and a wide variety of sports is essential for a rounded education and should be available to all at whatever age and from any background. There are multiple academic studies and ample evidence that a combination of exposure to both STEM subjects and the arts enhances our ability to think logically, to find an optimal solution, to reason and debate rationally with others, and to easily spot and challenge poor information, all of which makes us better rounded, more productive, and yes, useful human beings, learning how to cooperate civilly together for a win-win global gain for the whole of humanity. Bob Kowalski has joined us this evening to try to demystify the current popular discussions of the advantages and potential dangers of artificial intelligence, and to clarify the difference between genuine AI and what are actually just non-AI advances in digital technology and robotics. Over to you, Bob.
What is AI and how can we live with it? Can we live without it? Will it be possible in the future to live without AI because it pervades so much of our life, even today? I think in order to understand AI, artificial intelligence, you need to first think about human intelligence and how the two compare. Is there any difference between human intelligence and artificial intelligence? Is there such a thing as human intelligence? Well, I want to argue that there are two kinds of human intelligences, two kinds of human thinking. One is conscious, deliberative, verbal. We can call it symbolic as well, because the words we use symbolize things that we talk about in the world. It allows us to communicate from one human to another, often very complex ideas. The other kind of thinking is subconscious, intuitive, nonverbal. We can communicate with others using this subconscious kind of thinking by showing how to tie your shoelaces, for example, and then this can be assimilated by the recipient and they can follow your lead. Now, in the human, conscious and subconscious thinking collaborate, they cooperate with one another, they help one another. Conscious thinking can often be what we call compiled using computing terminology. That is to say, you can take conscious thinking and you can transform it into instinctive responses. We do this all the time. When you learn to write letters, you had to think very hard how to move your fingers. After a while, this becomes totally subconscious. You don't even know that you're doing it. You just write and you don't know. Often you write a word different from what you intended. It's so automatic. When you learn a musical instrument, you have to be very careful about where you place your fingers. After a while, you don't know where your fingers have gone. They've done their own thing. All of these activities, so many of them, are first assimilated through conscious teaching very often, and then become subconscious. But the opposite can also happen. You can also have a subconscious instinctive reaction to things and then step back from that and ask yourself, how did I do that? How can I explain this to somebody else so that they can replicate my activity? For example, if you're an artist and you know how to draw, you might be an art teacher who puts the activity into words so that someone else can do that better than they would if they were just experimenting totally on their own. And similarly, in medicine, medicine is an art or is it a science? Well, maybe it starts out being an art. You have an instinctive understanding of what symptoms are associated with what that medical illness. But if you put your mind to it, you might be able to articulate those relationships and put them into words and communicate that to somebody else, both to explain why it is you've come up with a diagnosis, but also to train younger people to also become medical practitioners. Logical thinking, which is a form of conscious thinking, can help humans to be more rational. Now, there's a difference between being logical and being rational. The bigger thing is to be rational, because to be rational means to act appropriately in the current situation. And in order to do so, you need to compare different alternative courses of action. Shall I run or shall I fight? What would the consequences of running be? Will they call me a coward? If I fight, will I lose? And you need to think through the consequences before you make a decision. Conscious thinking can monitor our instinctive responses. So, for example, if I'm driving from here to go back home, I might tend to take the wrong turning because I've not done this recently, and I might have a more common activity, and I need to correct that. Where are my keys? I come home and I put my keys somewhere, then when I need them, I don't know where they are. And then I have to think consciously. So first, subconsciously, I put them somewhere. Consciously, I now need to think, could they be in the pocket? What clothes did I wear? Could they be near the doorway? And then when you think through all the alternatives and you start exploring, and there's only one option left, you don't have to think anymore. You just go directly to the only place it possibly could be. And conscious logical thinking has overridden and monitored and allowed you to cope with your subconscious reflexes. So let's now talk about AI. So if this is the way humans are, what about AI? If you read about AI, you may get the wrong impression. You may get the impression there's only one kind of AI. But no, there are two kinds of AI. Two kinds of AI, just like there are two kinds of human thinking. There's the symbolic AI, which is verbal and logical, and it's been used for many applications. Applications, for example, like in my PhD in Edinburgh in 1970, for automating proofs of mathematical theorems. Crazy idea, but nonetheless, it has been done. It can be done. For practical reasons, purposes, it's been used to validate computer programs to show that they actually perform the functions that they were intended for, because the programs could be quite inscrutable, and you need somehow in safety critical applications in particular to know they're doing what they're supposed to do. We've used it also for legal reasoning, for implementing logical representations of legislation and other rules and regulations. And we've been able to apply it in individual cases, augmented with human judgment in order to determine whether or not and under what conditions a person might be able to benefit or from legislation of one kind or another. Expert systems also have been historically one of the major symbolic applications of AI, which were quite dominant and prominent in the 1980s and 1990s. Medical expert systems, and they exist today. They still reason logically using the scientific knowledge that medical experts have concerning the relationship between symptoms and diseases and treatments. So there have been many successes in symbolic artificial intelligence, but in the last 20 years or so, it's the sub-symbolic approaches to generating intelligence that have come to dominate. Sub-symbolic systems that use neural networks that don't have an obvious logical interpretation, that use machine learning using massive amounts of data gathered from all over the internet. And there have been massively successful examples of this. For example, with image recognition, recognizing your face when you turn on your laptop or your smartphone, diagnosing an image, a medical scan, and determining whether you might have a tumor or not. And of course, these often exceed now regularly medical human expertise, robotics with self-driving vehicles. The promise is that self-driving vehicles would be far safer than human-driven vehicles because they will have learned through massive amounts of data what to do in what kinds of circumstances. Large language models such as ChatGPT, which give the appearance of understanding natural language. And these are both very powerful but very frightening because they often give wrong, erroneous, and biased results. But the best way to understand them is that they're just really an elaborate form of predictive text. When you type a message on your smartphone, the phone has data about what kinds of next words people have used in the past, and it predicts what the next word might be. Well, with ChatGPT, they have massive amounts of data, and they're able to put this predictive text together in such a way that they can generate, seemingly coherent answers to questions. But AI systems, no matter what kind, whether they be symbolic or sub-symbolic, they need to explain their results. They need to explain their output so that we humans can decide whether to trust those results or not. Symbolic AI systems, remember there are two kinds of AI systems, and they correspond quite closely to the two kinds of human thinking. So symbolic AI corresponds quite closely to conscious AI, which is deliberate, and sub-symbolic AI corresponds quite closely to subconscious intuitive human thinking. But whether the AI system is symbolic or sub-symbolic, it's important that we humans can trust them, and for that purpose, it's necessary that these systems, in some way or other, be able to explain how it is or why it is they're recommending perhaps a particular course of action. Now, symbolic systems, which are often logic-based, are potentially explainable by design. They're designed to be explainable. They understand, they use the same language as we do, in effect. Whereas sub-symbolic systems, they can only wave their hands, and you don't know whether you can trust them or not. So how do we cope with these sub-symbolic systems? Well, there are two ways to do that. One is by combining in a hybrid manner sub-symbolic and symbolic systems, and this is happening more and more these days. Last couple of years have seen a massive explosion in terms of systems that are monitoring, in particular these large language models, ChatGPT type things. They're now being combined with logic-based models that take the output and convert it into logical form, reason with the logical form, go back to the ChatGPT large language model and see whether the kinds of results that the large language model are providing correspond to what the logic is saying ought to be the case. But even then, we humans have to trust both of these systems, even if they're hybrid and even if they're monitoring each other in the same way that our own conscious and subconscious thinking monitors. That is to say, our conscious thinking monitors our subconscious thinking. A good example of these hybrid AIs is new developments in self-driving cars. So if you have a self-driving car, it's great that they're safer than human-driven cars. But what if there's an accident? I mean, how do we know whether they followed the law? How do we know what rules they used? They probably haven't used any rules at all. But can we? Is there some rule that is compatible with what they've done? What are their ethics? If there's a collision, have they chosen to avoid damaging their own car at the expense of damaging possibly a pedestrian or another car? So we need to know exactly, in human intelligible terms, what the ethics and what rules they use for operating. But I'd like to finish by focusing on education, because I think we need to educate. We need to educate children. We need to educate adults. And we need to teach them that there are two kinds of AI. It's not just one kind of AI, and that these two kinds of AI need to complement one another. And we as humans need to develop those skills that the symbolic AI systems have developed. We need to improve our ability to reason rationally, to logically monitor our instinctive automatic responses. We need to understand better how to interact with computers. So although not every computer program is an AI, nonetheless, they have much in common, and we need to be able to understand the way computers work in general. And logic-based systems are much closer to the way the vast majority of ordinary non-AI programs work. But it's not just about being more comfortable and being able to cope better with the computer world and the AI world and the world of machines. It's also about improving our own human intellects. It's about improving our own ability to control ourselves. And also, logic-based AI and symbolic AI, with its clarity of thought, can also be used by people to improve clarity of their own thought, to improve the clarity with which they communicate with others, so that they express their thoughts in a logical manner, so that one thought follows from another. And finally, we should teach the difference between truth and falsity. And this is very important in today's world because more and more we're seeing false news. And AI is potentially very dangerous because it can make false news seem plausible. We need to monitor that both with symbolic AI, but also with human intelligence.